Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and as always, I'm joined by my co-host, Victor. Before we dive in, we'd love it if you could rate our podcast on your listening platform. It really helps us reach more developers like you.
That's right, Sheila. Your support means the world to us. Now let's get into today's topic. We're continuing our journey through Chapter 5, Networking in P2P Systems, and we'll be discussing gossip protocols.
Ooh, gossip. Sounds intriguing. But before we start, I have a quiz question for our listeners. Here it is. In a network of 1,000 nodes using a gossip protocol, how many rounds of communication would it theoretically take for a piece of information to reach all nodes if each node tells two others in each round?
That's a great question, Sheila. It really gets to the heart of how gossip protocols work. Listeners, think about how information spreads in social networks. This question is all about the speed and efficiency of information dissemination in large networks. Don't worry if you can't figure it out right away. We'll reveal the answer at the end of the episode.
Now, Victor, let's start with the basics. What exactly are gossip protocols?
Gossip protocols, also known as epidemic protocols, are a method of spreading information in distributed systems, much like how gossip spreads in social networks. In these protocols, nodes in a network periodically exchange information with a few randomly selected peers, eventually disseminating the information throughout the entire network.
Oh, I see. So it's like if I tell a secret to two friends, and they each tell two more friends, and so on. Is that a good analogy?
That's an excellent analogy, Sheila. It captures the essence of how gossip protocols work. Now let's dive a bit deeper. There are two main types of gossip protocols: rumor mongering and anti-entropy.
Rumor mongering sounds fascinating. Can you explain that one first?
Of course. In rumor mongering, when a node receives new information, or a rumor, it randomly selects a few other nodes and sends them this information. This process continues until the rumor has spread to a sufficient number of nodes or a certain time has passed.
I see. And what about anti-entropy? It sounds like something from a sci-fi movie.
Anti-entropy is a bit different. In this approach, nodes regularly choose another random node and exchange all their information, resolving any differences. This helps ensure that all nodes eventually have the same information, even if some messages were lost or delayed.
That's interesting. It seems like gossip protocols could be really useful in large networks. But I'm curious, what are some of the advantages and disadvantages of using these protocols?
Great question. The main advantages are scalability and robustness. Gossip protocols work well in very large networks and can handle node failures gracefully. They also provide eventual consistency, meaning all nodes will eventually have the same information.
Those sound like significant benefits. But what about the downsides?
The primary disadvantages are that gossip protocols can be slower to propagate information compared to some other methods, and they can generate a lot of network traffic. Also, they typically provide only eventual consistency, not strong consistency, which might not be suitable for all applications.
I see. So it's a trade-off between scalability and immediate consistency. Can you give us some real-world examples of where gossip protocols are used?
Certainly. Gossip protocols are used in various distributed systems. For example, Apache Cassandra, a distributed database, uses a gossip protocol for failure detection and maintaining a node's view of the cluster state. Another example is the Hashicorp Serf library, which uses a gossip protocol for cluster membership and failure detection in distributed systems.
That's fascinating. It seems like gossip protocols are particularly useful for maintaining the overall health and state of distributed systems. Are there any common misunderstandings or pitfalls developers should be aware of when working with these protocols?
Absolutely, Sheila. One common misunderstanding is that gossip protocols guarantee immediate consistency. As we discussed, they provide eventual consistency, which means there can be periods where different nodes have different information. Developers need to design their systems with this in mind.
That's a crucial point, Victor. Any tips or best practices for implementing gossip protocols effectively?
Great question. One key best practice is to carefully choose the gossip frequency and the number of peers to contact in each round. Too frequent gossip can overwhelm the network, while too infrequent gossip can slow down information propagation. It's also important to implement a good random peer selection mechanism to ensure information spreads evenly across the network.
Those are valuable tips, Victor. Now, I think it's time to reveal the answer to our quiz question. Can you remind our listeners what it was?
Certainly, the question was, in a network of 1,000 nodes using a gossip protocol, how many rounds of communication would it theoretically take for a piece of information to reach all nodes if each node tells two others in each round?
And the answer is approximately 10 rounds. This is because the number of informed nodes doubles in each round, so it follows the pattern 2, 4, 8, 16, and so on. After 10 rounds, we'd have informed 2 power 10, half 10 to 24 nodes, which covers our network of 1,000 nodes.
Excellent explanation, Sheila. This really demonstrates the power and efficiency of gossip protocols in large networks.
Thank you, Victor. To wrap up, let's summarize the key points we've covered about gossip protocols. 1. They're a method of spreading information in distributed systems, similar to how gossip spreads in social networks. 2. There are two main types, rumor mongering and anti-entropy. 3. They offer great scalability and robustness, but provide only eventual consistency. 4. They're used in real-world systems like Apache Cassandra and Hashicorp Serf. 5. Careful tuning of gossip frequency and peer selection is crucial for effective implementation.
That's a great summary, Sheila. I hope our listeners found this deep dive into gossip protocols informative and engaging.
Absolutely, Victor. And to our listeners, remember to visit crashcasts.com, join our Discord community, and support us on Patreon if you enjoyed this episode. Your engagement helps us create more content like this. Until next time, happy coding.